Lesson 73 was about quadrilaterals. 74 is about triangles. So in this lesson, we're going to learn how to find the area of triangles. So watch as I classify triangles based on their length and angle measures to figure out their names, and then how I can accurately find the area of triangles algebraically once I have two very important dimensions. And finally, how I manipulate the area formula to find any missing length given area or another dimension. I'm actually not going to do this in the model part, but it will come up in some of your problem sets. So just make sure you're substituting with the known dimensions to find the unknown variable using EE skills. You know how you have a first and last name? Well, triangles can have two names too. One based on its angles and the other one based on its sides. So we're going to look at different triangles and looking at the angles first and then looking at the sides. So the first triangle has 3 equal angles. And we call this an equilateral triangle. Now, if your triangle has an angle that is bigger than 90 degrees, then we call it an obtuse triangle. If your triangle has an angle that is equal to 90 degrees, then we call it a right triangle. So you see how its name is based on this angle, an obtuse angle, a right angle. And if your triangle has 3 angles that are less than 90 degrees, these are acute angles. So this is an acute triangle. Now the second set of names it can have are based on its sides. So if it has 3 equal sides, it's still an equilateral triangle. I'm just going to put a symbol for triangle. Now if it has 2 equal sides, then we have an isosceles triangle. I often spell this wrong, so isosceles. And if it has 0 equal sides, then we call it scalene. The scalene triangle. So any triangle can have both names. So for example, let's say I have a 90-degree angle and it has 2 sides that are the same, then I can call it a right isosceles triangle because it is a right triangle and it is an isosceles triangle. I could have a triangle, one obtuse angle and no equal sides, so I can call it obtuse or scalene. Both would be true. And that's what we're going to do today. We're going to practice not only naming triangles, but figuring out the area of triangles. Hit pause and jot this in your notes. Let's practice finding area of a triangle. Now, the formula we're going to use is area equals 1/2 base times height. You might see it as base times height divided by 2, but I think that looks a little bit more complicated. I'd rather work through it with the fractions, and I will with my work with my calculator. Why is it 1/2 base times height? Well, we know base times height is the formula for area of a parallelogram, and the reason it works is because when we look at triangles, triangles have an area that is half of the parallelogram. Why do I say half? Because they have the same base and height. Those two are the same, but my triangle is only half of that whole area. So we do base times height and then we divide it by 2 to find just the area of a triangle. Even in this next one, I'm going to, let's just use parallel lines. So here we go. Same thing. My base, my height, would give me the area of this entire parallelogram, but with my triangle I only want half of that. So this triangle with this base and height only has an area of half of a parallelogram with the same base and height. So that matters. All right, so I'm going to use a formula. Area equals 1/2 base height. Let's substitute. Area equals 1/2 15 times 20. So here's 15 times 20, and that gives us 300. Area is 1/2 of 300. And half of 300 is 150. Let's try with the second triangle. Area equals 1/2 base height. Same thing. I'm just substituting 1/2 4 times 3. So 1/2 times 12, and half of 12 is equal to 6. So the area is 6 square inches. Make sure I have my units in there as well. Okay, so hit pause so you can jot this down. This is the formula we're going to use whenever we're finding area of a triangle. Let's start by naming these triangles using information we have. So with this first triangle, I don't have this third side. I can see these two sides are different, so it's possible if this side is 11, it is isosceles. If it's anything else, it would be scalene. So I don't have enough information here. But looking at the angles, this is definitely less than 90. This one's less than 90. And this one up here also looks less than 90 degrees. So more than likely, this is an acute triangle. And I'm saying that it's less than 90 degrees. If it was 90 degrees, it would have that little symbol there. My second triangle has 3 sides. They're all different, so it's absolutely scalene. And because the sides are different, all my angles are also different. If they were the same, they would be equilateral. That is not true. And these are also acute. So let's figure out the areas for these triangles. So 1/2 base times height. 1/2 15 times 8. So 15 times 8 is equal to 120. So half of 120 is 60. And since I don't have the units, I'm going to put units squared. That's my area for my first triangle. Now for my second triangle, I have a base. I don't have a height. I just don't have enough information to find the area for this triangle, unfortunately. So here we go. 1/2 base height. I would only have 1/2 times 6, and I don't know the height. So I cannot figure out the area until I know the height. So hit pause so you can jot this one down into your notes. Let's work through this last one. I'm writing raise. The banner hanging in Nate's bedroom has the measurements shown below. What is the area? All right, so it's definitely a geometry problem. Even though the base is usually at the bottom, if I were to just move this triangle around, the area doesn't change. So I'm going to use this as a base and 40 as my height. And I'm going to use my formula, and I'm going to sub my dimensions. So area is equal to 1/2 base height. Area is equal to 1/2 18 times 40. So 18 times 40, I can do that part, and I get 720. So automatically I know I'm going to have to figure out 1/2 of 720. So these two I'm eliminating, because I know my answer should be smaller than that. 29 is also I'm eliminating, because there's no way 18 times 40 was going to be 29. It was way too big a number. So let's figure out what is 1/2 of 720, and it is absolutely 360. Hit pause and jot this down in your notes. And You did a ton of information. You now know how to name a triangle based on sides or angles, and we're going to use the formula 1/2 times base times height to find area of triangles. Get a lot of practice in Math Marbles. You may need to use your calculators to help with calculations and get this practice. I know you can master today's objective. I'll see you in the next one. Take care.